Good morning. I am K. Palanivel, Assistant Professor of Mathematics, SNS College of Technology, Coimbatore. Already we have seen the topic Cauchy's integral formula and Cauchy's integral theorem also. Next going to see the topic is Cauchy Residue Theorem. If f of z is analytic at all points inside and on a simple closed curve C except at a finite number of points z1, z2, z3, etc. zn inside C, then integral over C f of z dz equal to 2 pi I into sum of residues of f of z at z1, z2, etc. zn. This one is called the Cauchy Residue Theorem statement. F of z is analytic at all points and simple closed curve C. The finite number of points z1, z2, etc. zn. Therefore, the formula is very important one. Integral over C f of z into dz equal to 2 pi I into sum of the residues of f of z. Proof. Given that f of z is not analytic only at z1, z2, etc. zn, draw the non-intersecting small circles C1, C2, etc. Cn with centers at z1, z2, etc. zn and radius ρ1, ρ2, etc. ρn lying wholly inside C. The diagram is there. Listen, C1 and Z1, C2 and Z2, C3 and Z3. The small circles are drawing this whole circle. Next, then f of z is analytic in the region between C and C1, C2, etc. Cn. Therefore, integral over C f of z dz equal to, therefore circle, the C is the whole circle, the split of the circle 1, circle 2, etc. circle 3, etc. circle n. Therefore, the formula is changing this order one. Integral over C1 f of z into dz plus integral over C2 f of z into dz plus etc. plus integral Cn f of z into dz. Now z1, z2, etc. zn are the singular points of f of z. Residue of f of z into z equal to zi. The coefficient of 1 by z minus zi in the Lorentz series of f of z about z equal to zi by definition of residues b1 equal to 1 by 2 pi I integral ci f of z divided by z minus zi whole power 1 minus 1 into dz. The formula is substituting 1, 2, 3, etc. C1, C2, C3, etc. Cn are taking the integral limit is ci. Therefore, since bn equal to this one is called b1, next bn equal to 1 by 2 pi I integral over ci f of z divided by z minus zi whole power 1 minus n into dz. 1 by 2 pi I into integral over ci f of z by z minus zi into dz. 1 by 2 pi I integral over ci f of z dz whole f of z into dz. Integral ci f of z dz equal to 2 pi I into residue of f of z at z equal to zi. From 1 and 2, integral over C f of z into dz equal to 2 2 pi I into residue of f of z at z equal to z1 plus 2 pi I into residue of f of z at z equal to z2 plus etc plus 2 pi I into residue of f of z at z equal to zn. Therefore, 2 pi I into residue of f of z at z equal to z1 plus residue of f of z at z equal to z2 plus etc plus residue of f of z at z equal to zn. Therefore, 2 pi I into sum of residues of f of z at z equal to z1, z2, etc zn. Therefore, 2 pi I into summation overall I into Ri. This one is the formula of Cauchy Residue Theorem. Thank you for watching.